Good afternoon, everyone. Thanks for joining. This is Pecan Street's Smart Distributed Energy Resources webinar. We're going to give everyone just a minute to join and then we'll kick things off. So just sit tight for now and then we'll get started. Okay, it looks like we've had quite a few people join, so I think we can go ahead and kick things off. Again, if you're just joining, this is Pecan Street's Smart Distributed Energy Resources webinar. And to get started, I'm going to hand it off to our moderator, Pecan Street's Chief Technology Officer, Scott Hinson.
Thank you, Clayton. We are very pleased to have you here closing out your week with us on today's webinar about smart distributed energy resources. Before we get on to the topic of the day, a few housekeeping items. We've got a chat function for questions. All of the viewers are muted, so if you have any questions that you'd like us to address, please put them in that chat panel and we'll try and respond to questions at the end. Or if there's a good spot during the flow of the program to ask one or two of them there, we'll do it there as well. So please don't hesitate to ask those questions. We'd love to hear what else you'd like to know about today's topic. A bit of background on Pecan Street's DER research. We have three core capabilities. We have our field research, our database of data that we've been collecting for years, and our lab. And we do research into smart DERs, inverters, microgrid systems, energy storage systems, demand response systems across all three portions of that research that we do. We have a number of, many of our volunteer participants have rooftop solar because we monitor the energy at the circuit level on a second-by-second basis with power quality information. We know how solar fits into the generation and demand profiles of a residential structure. We know how it impacts the grid interface at those terminals in terms of power quality and things like that. And so that data is available to, and we like to make that data available to our commercial partners as well as academic researchers throughout the world. And then lastly, I already mentioned it, but I'll mention it again because we do a lot of testing. You can see some of the stuff behind me. There's more things that I can't show you on the other side of the video here, where we are testing devices that are soon to be released to the market or are on the market, but the functionality of those devices are not fully being utilized. Things like some of the essential smart inverter functions and stuff like that. We do testing on that all the time. So all this is to say is that we look at distributed energy resources as a core part of our work. It is very important to us. We think that there is, at Pecan Street, we think that there is quite a bit of missing functionality or functionality that is present and not being used. And we think that there's some functionality that is also missing in terms of adding to the feature set that we'd want for continued adoption of solar and increased penetration of solar across residential, commercial, and industrial spaces. So we have a great panel for you today. I'm very excited that everyone has agreed to join. So I'm gonna turn it over to our first panelist. Hussein, would you like to introduce yourself and tell us what you're working on?
Great, thank you, Scott. I'm pleased to be here with you guys and speak about this issue. My name is Hussein Ghassanpour-Aghamoki. Last name is hard to pronounce, but Hussein is good. I'm with Eaton Research Lab. We are a team of the mainly researcher for power system working on different technology for our business at Eaton. And it gives us the opportunity to work on the different stuff that's usually exciting for different levels from home level to distribution and utility. So that's my background. Today, I'm going to talk about the challenges that I see based on my experience around the adoption of the DR and how we can address some of those challenges. Next slide, please. So the main question often come up is, what is the main kind of a barrier for adoption of the DR? Of course, we achieved a lot in US during last couple of years around the DR adoption, reached to 10% energy penetration at this level, but still there is a long way to go, and still lots of barrier exist today, specifically in the technology and in the policy aspect of it. So one of the things that I think is really important when it comes to the policy is we don't have a universal kind of a strategy when it comes to the policy in the US. And it's kind of a wild west. Every region, every market, every state has its own kind of policies and incentive. And it is hard to imagine all of the problem can be addressed by one set of policies. So we probably need more kind of coordinated policies toward the smart grid, smart DR adoption going forward. Some of the main kind of barriers in the policy, according to EPA, is utility rate structure, lack of interconnection standards, and also the permits that usually require for larger DR in the system. But to me, the most important thing that need to be addressed when it comes to policy is we should be able to incentivize every players in the smart DR domain, from the system operator to the end user and the aggregator and everyone. Until we don't address that and we incentivize everyone, it is hard to imagine that you would reach to the level of adoption that we are planning to going forward in 2030 or 2035. But also, still, there's some barriers when it comes to the technology as well. And that's the part of my job that I'm excited for. The lack of the suitable or let's say universal communication and data infrastructure, something that can address all of the problem again for all of the players, is something that we need to more look into. And I think Pecan is really doing a good job on this part, but it's still a long way to go. Cybersecurity threat is becoming more and more important right now in power system, and that's one of the issues that we need to address. And when it comes to the power system, specifically in the distribution level as well as the secondary network, still we are facing a lot of limitation, and utilities seeing the DRs as a burden rather than kind of a tool for them to get advantage of these new technologies. For example, in urban area, we know that the IEEE standard today and also the practical approach that utilities has is they would not allow any reverse power flow because of the protection limitation that we have in the urban areas. And those kind of limitation will limit how much DR we can put in the system. So next slide, please. So again, to me, one of the main barriers is not everyone has the same goal when it comes to the DR adoption. And also, one of the key players that need to be fully incentivized is, in my mind, is utilities. When you look at all the players in this domain, they have their own kind of goal and priorities, and not necessarily those are mutually exclusive. So you would see that, for example, utility want to sell more energy at the night when they have a light load, but still customers or aggregator want to decrease the amount of energy cost. So that's how this kind of environment is working. Specifically for utilities, there are a new survey that happened among 900 of the utility stakeholders, and 50% of them actually seeing the behind the meter DR as a threat today, because they think this affect their business because the aggregator and everybody else coming to play in the role that traditionally utility has. And they think they should get ahead of it. And also they seeing all this burden of the DERs in their system because there are still lots of technological challenges that exist today that need to be addressed. And to me, if we could not address this kind of fear and problems or barriers, we would not reach to a level of the DR adoption that we wanted in future. Next slide, please. Also, one of the questions that always brought up is what make a smart DRs or a smart systems for the future. And to my mind, we usually had a central approach, and then recently, I guess in academic world, they are talking about the fully distributed or multi-agent based kind of approach to controller. And each of them has its own advantage and disadvantages. And to my mind, the only actual solution is the kind of a hierarchical control. And a smart system for me is a system that you have intelligence in each and every level of the hierarchy control, from the device controller to home controller to centralized controller in a virtual power plant or a distributed management system, and then up all the way to the to the market and also the market operation. So that is the important part. And if we could not create a platform that every single player can leverage and get advantage of, I don't think we would reach to the level that we wanted for a smart system if we wanted to put this name out of it. So that's why in Eaton we work on the different projects to enable using DRs and demand response load or flexible loads for grid services, either in the distribution level or even in the transmission level. And different projects throughout the year, I think, lead to the current project. If you go to the next slide. So this is the current project that we just recently get funded from DOE, I think about 3 weeks ago. And it's about the operationalizing the behind-the-meter DRs for grid services. And I think this platform can help us to achieve all the things that I've discussed here. Next slide, please. So essentially, what we are offering to provide as a new technology or propose as a new technology is using the infrastructure that today utility has to enable all the players along the DER domain. Essentially, starting from the home, we are saying that we don't necessarily need new platform to manage the home. Probably smart meters that today exist in each home. If we can add more intelligence on that, it can actually address both required need for grid services in the upstream, but also managing all the DRs and the flexible load at home level, and save some money and give incentive to the end user. As well as for the utility, not only they can play the role of the aggregator based on this new platform, but also they can somehow change their business model and allow third-party aggregator to use their existing infrastructure and use that to kind of increase the adoption of the DR in their system, and then take advantage of having those data in their operation. And finally, this platform and the control kind of central control intelligence would allow the aggregator or utility to participate in the wholesale market and different ancillary services and demand response. Next slide, please. So if I wanted to share a little bit more detail for the technical aspect of it, in the home level, we are thinking of adding more intelligence around load disaggregation, around estimation of the available kind of the services, and then kind of communicate this to the central level where you have a load forecast, PV forecast, and also can have a stochastic optimization approach to create more bidding for market or other kind of ancillary services. And then the feedback or comment to all the houses can be a kind of a pseudo pricing where that actually represent all the limitation in the network as well as the opportunity of the real-time market pricing. So I think with that, I'm just closing my first slide here. and hopefully we can have more discussion in the Q&A. Thank you.
Thank you. That was awesome. Thank you so much. Next, I'll turn it over to Bill. Bill, go ahead and introduce yourself and take it away.
Thanks, Scott. Good morning, everybody. And now for something completely different. I'm the CEO of Bandera Electric Cooperative. You can go ahead and hit the next slide. Our vision is reimagining rural America. And while a lot of focus has been put on urban areas and basically the deployment of DER in urban areas, we've been focused on deployment in rural areas. And it has a lot more challenges, as you might expect. So this is just a quick slides. This is our service territory. For those who aren't familiar with Bandera Electric Cooperative, we're about 45 miles northwest of San Antonio. Next slide, please. So as an electric cooperative, you know, we're nonprofit. We have 37,000 electric customers. We have a program where we're taking fiber to the home. We've surpassed now 50% of all of our members now have fiber access. It's gigabit into the home. So we have 6,700 broadband customers, about 800 phone customers, 310 solar and energy storage customers, and 181 ApolloWare customers. And I'll talk a little bit more about ApolloWare in a minute. That represents about 3.7 megawatts of dispersed fleet, solar fleet in our fleet that we can operate. 574 kilowatts of energy storage in the form of various Tesla power walls scattered throughout the hill country of Texas. Next slide, please. I'll move through this pretty quickly because I know they'll probably want to have time for questions. So this has really been our business model. It's adaptive. I think we're a pretty unique utility. We're really focused on customer service and engaging and empowering our members with products and services that benefit all of us. And so in 2016, we launched BEC Solar. A lot of our members were getting, let's say, duped by maybe unethical solar contractors who were overcharging and underperforming. And of course, we were put in a defensive mode as an electric utility. So we decided to get out in front of it, design and operate and build an offer for our members, rooftop and ground mount solar based on their load profiles to ensure that they were sized correctly. A lot of times contractors will want to oversize. They'll sell you glass. That's what they're in business to do. But that is not necessarily the most economical for our customer. Obviously, broadband is a big deal. We're hearing about it now, work from home. So in 2017, we started deploying our fiber network. We now have more than 1,500 miles of fiber throughout the hill country. You know, that is not only the basis for providing broadband service, it is an essential part of ApolloWare. It is an essential part of our behind the meter solution because as you all know, data communication is the big issue. Getting data back, I think Scott showed in his first slide, the tremendous amount of data that is generated when you start monitoring things at a second level. It's voluminous. And so being able to harness that correctly has been a challenge, but also you have to have a secured communication network that can handle it. And so the fiber network also enables us to provide that. DEC Analytics is really ApolloWare. We started working on ApolloWare, which is our own DERM system, essentially, for lack of a better description. It's cloud-based. It allows us to monitor up to 12 devices behind the meter, primarily solar storage, but if you have large appliances, we do that too. And then just recently, we were awarded by USDA RUS. ApolloWare was approved as an energy efficiency device, so we've gotten some good funding from the USDA for full deployment. Next slide, please. Just kind of to show you a couple snapshots of what it looks like. So ApolloWare from a utility perspective, what we can tell is if solar rooftops have been designed poorly here, the top slide to the right, you see that obviously there's been more panels than the inverter can handle, and it's clipping the wave. We also notice that inverters fail. and quite frequently inverters fail. And so it's an important understanding that the utility has to understand that this stuff is not necessarily utility grade components that are being put in on their system. So it's very important that the utility have the ability to monitor this for power quality at a very, very granular level. As I think Scott said, 1 second, and we have the same. It's 1 second interval data, which is pretty granular. Next slide, please. So this is just my account. So I have Apolloware at my house, and this is just a snapshot of my cell phone. So we have an app, and that basically our customers download, and this gives you a real-time indication of what you're using and what your monthly bill is if you're going to continue to use at the current pace. So it updates every 5 seconds. And then I'll just go to the next slide because it just, again, these are just kind of screenshots. Again, in my case, what I found out that my pool pump actually uses more energy than my air conditioner, and that's a pretty scary thought. Pool pumps are notoriously just completely inefficient. They're just cheap motors and they just run and run and run. And what I've also found is if the filter gets clogged, now you really are going to consume energy. So it's a way that we actually can apply this to help our members. And we've installed now over 200 Apollowares throughout our service territory. We hope to have 1,000 by the first quarter of 2021. And we continue to go from there. So next slide, please. This is my last slide, just finish it up, just reiterating, we did get a 0 interest loan from USDA for 20 years for the implementation of Apolloware as part of an energy efficiency program. When you talk about getting DER out there, it has to save money for the customer. And so what we have to have is the data to support energy efficiency, and that's what we found. So we're really happy that DOE has sponsored us on that regard. So with that, I will turn it back over to Scott. Thank you.
Thank you. That is our experience mirrors yours. We found when we looked early on with our solar programs back when we were still doing even 1 minute basis, that we saw a number of folks where the inverter size wasn't right. We'd see those clipped waveforms where they had a minor shading issue that was dropping 20% of their production in the morning or something like that, right? So it, some analytics running across those is really handy. And you're also not alone in finding out that pool pumps are a real cost. You're not the only one to find that one out. So yeah, so your experience along the lines of, inverter failures and systems being offline, we've seen that too. That is everywhere. So yeah. Awesome. Thank you. John, why don't you go ahead and introduce yourself and talk to us what you're working on.
Yeah, thanks, Scott. Yeah, so John LaFollette, everybody. Appreciate you making time for the panel today. Yeah, so I lead the energy system integration and storage research team in the Shell New Energies Research and Technology Department. We're based in Houston, and we have folks in Amsterdam and Bangalore as well. And it's interesting, Bill, when you kind of talk about rural distributed energy resources, I always tend to use the analogy and think about, I grew up in rural Oregon, and when everybody where I grew up, we all had a distributed resource, and it was water. And, that allowed us to have lower cost water, and, we could be resilient. And so when I think about distributed energy resources, I often think about, how do we enable people to have a more resilient, reliable, and efficient power grid? We're through a distributed network of resources. And of course, we're talking about how to cooperate, how resources can cooperate and alleviate some of the problems on the grid today. But I just wanted to add that. And then also, so one of our facilities, our research facilities, we have a microgrid test facility in Houston, where we, since 2016, have been looking to understand, and develop integrated product offerings for commercial and industrial customers that include battery energy storage, solar, reciprocating engines, and also globally trying to understand EV flexibility as well. But we've seen it's not only residential solar inverters that drop out and fail. I will say that. I won't get into details, but it's not unique. So it's interesting when you,
John.
yeah, you know, when you do get hands-on experience with these technologies, what we've learned is that really the devil's in the details. And you know, you can install the capacity, but then, you know, putting together the right fit for purpose controls and optimization technologies that allow you to deliver on the promise of the value of those assets is challenging. But maybe to helicopter up a bit, Shell has been in the energy business for over a century, and then we've had experience and have assets with onshore wind for over 15 years, have a trading business that's been trading in power for some time. And then in 2016, we launched our new energies business that's led to our power business. And so we're working to be a credible player in all parts of the power value chain. And if we think about our customers, we have retail customers in the US and in the UK through different retail electric providers. And then also we're looking to help our customers understand their options for, you know, developing solutions that provide cleaner, resilient, and efficient power, and to meet those needs. So it's very interesting to be a part of that. And so we've looked at, you know, trying to understand various DERMS technologies and how those factor in, and, you know, what is the landscape. And as you said, you know, Bill, there's, you know, DERMS are challenging, and there are a lot of issues with, you know, leveraging all of these distributed energy resources, and we're working to try to understand solutions for that as well. So, you know, with that, I think I'll pause there and then give others a chance to speak.
Great. Yeah, the when we started looking at our residential data, the first year that we looked at, we spotted 20% of the solar systems had some sort of issue. Whether it wasn't necessarily that they had turned off and weren't coming back on, but they were missing days because of ground faults or something like that. It was 20% of the system. So yeah, it's. I mean, that number is staggeringly large, right? I mean, that's just a frighteningly large number. If you're, and there's no good way for, you know, a resident, you know, a residential customer to even look at it. It's not like the inverter beeps at you. It's not like you're walking past it every day. On an industrial scale, you've got people supposedly looking at it, but you can still have some gaps where you've missed something. So.
Yeah. I mean, it's an interesting example.
Should I go?
Go for it.
Okay.
Go
all right.
for it, Shashank. Let's not lose time.
So this is my name is Shashank Pandey. I work with Siemens as a software solution architect, and my area is basically the EMS, DMS systems, microgrids, and yeah, I've been working for Siemens for a while. So with that, yeah, I'll get started. Scott, next slide. So I'm going to touch base with, you know, just a few different things. Although, you know, it looks like a long list of things, it's really between Arnella and myself. So just a couple of slides on the, you know, technical capabilities of the DER controllers, and you know, what incentives currently we see, and what are the issues we see, and so forth. So let's go to the next slide, please. So the smart DER controllers, I mean, yeah, definitely in last 7-8 years, we have seen, you know, quite a bit of improvements. I mean, I remember that just a few years back, you know, it was not common to have even visibility into the inverters, and they were just doing what they were doing. Now with the communication capabilities, we basically get to see pretty much everything that's going on. And earlier, Scott mentioned that, you know, you can even monitor to the string level, you know, get a lot of data from these inverters, and that's a good thing for us, you know, where we want to develop applications making use of this data to make life better. But yeah, I mean, even with that, right now, as far as intelligence goes, it's still somewhat limited. You know that these inverters provide functions to, you know, change their power, reactive power based on certain parameters like frequency or voltage or power factor and so forth. But that's basically about the intelligence they have, which is not necessarily a bad thing. But of course, there is a lot of room to grow in future. And other good thing that basically we are seeing is that there is at least some standardization coming out of inverter. Particularly, I would mention the Sunspec, Modbus model. We obviously need more of that and on inverter and not only solar PV inverter, but various other assets like the flywheels and storage devices and fuel cells and so forth. Can we go to the next slide, please? So talking about the incentives available, that's another area that is, I think, is severely lacking. I think Hussein also mentioned that there are not much flexibility or not that many options for revenue generation. So much talked about today are the demand response programs, the time of usage tariff with demand charges where you can save some money. You have the long-term power purchase agreements, and in very limited cases, we see that some entities are participating in the energy market, wholesale energy market, and generating some revenue. But still, these things are limited, and I think that is one of the impediments in growing the share of these renewable distributed resources. Can we go to the next slide? So coming back to this grid decisions for grid resiliency or the intelligence, typically the ADMS is responsible for the distribution grids security and operation. The typical ADMS basically uses controls like the taps, the cap banks, and the switches to operate the grid. What we see is that the ADMS still has some serious gaps when it comes to taking advantage of the distributed energy resources on the system to make the grid more reliable. In fact, even now, most of the talk is that how big it is a problem to have so many DERs on the grid and so much of generation coming up on the distribution side. Hussein also mentioned that the reverse power flow is a problem. I will say it's problem pretty much everywhere. I mean, utilities have to change things, and it's pretty expensive to change the protection protection schemes and stuff to accommodate these DERs, and that remains a technological challenge that is actually solvable, but it is there. The DERMS, basically, there is a lot of talk about DERMS, and different entities we have seen have somewhat different ideas about DERMS, and in some cases we have seen that the gaps that ADMS has, expectation is that the DERMS should address or fill those gaps. But our view of this local control versus centralized control or distributed control, I think it aligns with what Hussein said. It should be hierarchical control, and it should be sort of every entity or every control system has their hierarchy, and they have autonomous they have some autonomy doing their own decisions and having their own intelligence to achieve their own objectives. Can we go to the next slide, please? So, so the real-time control options. I mean, as I said, is real-time control possible for at this scale? I don't know. I mean, probably not, because we still have constraints with the data that's that can be brought in on time to do the real-time control. If you really want to consider millions of resources that are online, like in California. But the hierarchical control is still a good option, and I think it's a smart way to go. And I think microgrids play a very important role in this whole picture, and having this autonomous decision making at a lower level, and the DERMS and the ADMS type of systems can actually guide these smaller areas to make their own decisions. And with that, I'll ask Ornella to jump in and talk a little bit about the microgrids.
Thank you, Shashank. So I'm Ornella Smailovic-Djedovic. I work with Shashank very closely on various Siemens digital grid systems. I'm managing the product microgrid management system within Siemens Research and Development. This system is all based and kind of we look throughout the Siemens digital grid throughout all of these systems that are covering EMS and a DMS market and a market side of it together with the microgrids, and we kind of are analyzing and integrating it all together into this whole DERMS vision. So as Shashank pointed out in here, I can give you a few more ideas of how we are thinking of microgrids within DERMS. So controlling the large utility covered areas are in a way impractical, and sometimes it ends up being questionable what can and cannot be controlled. This is where microgrids come into the overall picture. There could be a one or multiple microgrids connected to a main grid that can introduce various levels of autonomy. So grid can often be split into the smaller microgrids owned areas. Here, microgrids can do their own decision making and have their own autonomy within owned area or territories. So microgrids today have quite advanced technologies and various ways where they, again, are making their own decisions, and they can, can you go to a next slide away from, yes, here, please. So they today have quite advanced technologies and various ways where they, again, are making their own decision, and they are composed of different technologies to manage all kinds of distributed energy renewable resources, PVs and fuel cells and wind turbines and CHP, whatnot. So when you think of microgrids, to go to the basics, the reason why they exist in first place is the resiliency. So their basic needs are being there as backup for a power failure or the main grid for any reason where they can pick up and automatically establish a control. So another reason is energy arbitrage, buying power at cheaper rate from the utility or a main grid and use it when it is expensive by reducing the cost of supplying its own load. So microgrids are then set up to connect or disconnect to any of the two or from the grid based on that either the tariff setup as well. So another one is then demand charge management, to use microgrid to manage their power demand, or for reducing the carbon and reintegrated renewable energy. So if there is a need for just the resiliency, a simple PLC type of microgrid controller can suffice. But then microgrid in these cases are not as beneficial. So now most recent and very important one in use of microgrids is market participation. So this is where we get into an argument on microgrids' existence and its potential of a large benefit, much larger than what it is right now, as the right now generating revenue is more or less limited. So by this, we can now create an opportunity for microgrid owners as well as utilities to generate more revenue, and that is where highly sophisticated, predictive, algorithm-based microgrid controllers can step in. Next slide, please. Now let's see what is in that hierarchy of a control within the large grid. You have DERMS with connected advanced DMS system, ADMS in this case. you have ISOs, and then you have a microgrids. So what microgrid, with its advanced controller in place, can do is it can bid into the market through ISO and receive awards or dispatch instructions. So at the same time, there could be these two interfaces with overarching, DERMS and or ADMS, depending on the utility grid setup and structure. Utilities via DERM system can provide import and export limits, and then subsequently, controller provides import and export based on a bid awards from the ISOs. All that information exchange is already available, and in some cases commercialized, as we did within Siemens with some of the projects, as technology is already available. It's already there. What is missing, or to reference the name of this event, what is the missing link is, in this case, is the business model, monetization and incentives that are really not there yet. So this concept is all well ahead of its time in a way, technology-wise. We have to break that misconception that microgrids controllers are there only for resiliency and for a basic energy arbitrage and for this basic stuff that has been done so far. And we have to look ahead on what is the opportunity here and create a business model with all this technology that is available and get over this limited use of microgrids. And at this point, this will correspond to more of involvement of government incentives that should give more opportunity to microgrids to generate revenue and use the technology and pay part within the DERD management culture. Next slide. This is where when a system such as advanced microgrid controllers become very appealing and necessary. These systems go way beyond those PLC-based ones and provide sophisticated prediction type of system. The system has a capability to integrate into a wholesale market and subsequently into a larger overarching DERMS system. There is also a sophisticated algorithms to manage high penetration of renewables, which has been already commercialized. And as I mentioned earlier, technology is ahead of its time in comparison to a real commercial current use cases. It is now waiting for other things to catch up in their market and their management and create overall business model that provides monetized incentives. So when dots within DERMS and other advanced distribution system business models are connected and microgrid system technologies are available and ready to add yet another connection and close the loop, especially with its capabilities of market participation and energy exchange. So at the end of the day, with microgrid integration with DERMS, what we want to achieve is symbiotic relationship between utility and a customer. So within this relationship, with microgrids are not in use, it serves the grid through utility management. It is letting microgrids use their advanced system as an asset to play in much, much bigger market. This way, DERMS can serve the entire system and not just host or not just for a host or for a consumer. So within this concept, utilities do not see microgrids as, let's call it quote unquote load lost, but as an asset. And with this, then the main concept that should be looked at is that everyone benefits. Thanks.
Fantastic, thank you. So we've got a couple of detailed questions that have come in, but I'm going to ask a more sort of overarching one, and I think, Arnelli, I think I know what you're opinion / answer is going to be. Basically, if for the panelists, if you had a magic wand that you could wave to make one issue go away, is that a policy-based issue or is that a technology issue? And sort of where does that, where do you go wave that magic wand to make your lives easier in getting these assets deployed?
I think, as I mentioned earlier, and Shashank can step in here, we actually have we deal within Siemens with the multiple projects. But I think it's more of to go back to Hussein and to others, is that the policy. It's the commissioners that have to kind of agree of what do we try to achieve, what is really DERMS, and how to really use the technologies. Technology is there. We have a system, as I mentioned, that is already there and it's already capable of these things that are, and the problem is right now, technology is ahead of a time. I think various companies, various corporations, various scientists, we work with lots of universities, work ahead and create these very advanced algorithms. So technology is here. It is a matter of understanding the policy and standardizing, understanding what is the concept of the DERMS, how to really integrate, how to really visualize this. And at the end of the day, I mean, and how to benefit, how everybody can benefit, at the end of the day, who pays? Utility doesn't want to, bury the shoulder of their, ratepayers, and in some cases, microgrids don't want to, do that. But how do we really manage that among utility and the consumers? Is really comes top down, governments, incentives, policies, standardization, get more standardization within an exposure of DERMS and setup of the system within IEEE, and then we can get all the technology that is going on already applied.
Maybe I can add to that too. I think in general, so for DER asset owners to want to participate in some of these services that they can provide the grid, like ancillary services or demand response, there has to be an incentive. Those DERs were put there for a reason. If you look at rooftop solar or some of these volt bar services, they decrease the output, the overall output of the system. And so the owner of the DER is losing something by providing that service. And so they have to be compensated somehow, and that's more of a policy issue. And so we've had conversations around a microgrid system with an ISO and for a particular program that was in place for flexible loads, and said, hey, we've got this microgrid system that can provide this service. And the response was, well, that's not exactly what the rule was written for. And it seems like this is sort of a blob that can take energy and give energy, and it doesn't really fit. So we would have to do some rules changes for that to happen. And so I think I agree with Arnella that, the technology is there, but the incentives aren't there, and the rules are kind of getting in the way. And so just as with demand response, those flexible loads are now providing a service because the owners are compensated for the nuisance of flexing their loads. I think the same thing has to happen with DERs, including microgrids and other inverter technologies.
But then when you provide incentive on both sides, like with the microgrid, advanced microgrid controllers that do participation in a market, that's, I think, when you see the benefits. That's when individual DERs can see the benefit of participating into that market. And then you can see utilities having a benefit as well. And then when that all comes into a place, then of course, rules and an incentive for governments and the commissions are there to move ahead with that. But we, Shashank can say we already worked with a really fantastic project and you might hear about it at Commonwealth, Brownsville. where Illinois approved the setup. It's kind of like initial, kind of a pioneer way of looking into, combination of clustered microgrid who exchange the energy between each other, and then in correlation with utility. And this was approved by Illinois. But I believe the same concept was not approved for some other states. Shashank, you can step in, but I think this is what's really the major hurdle at this point, as we have examples, commercial examples.
Mm-hmm.
So, Arnella, John, so I want to add more. I think I agree with the general statement that you guys have here, that the policy is the driver, but also I wanted to add more perspective of, again, it's the combination of both, but I agree that if your business model is there, the technology can catch up. But when it's come to the market, we have to look at also the bigger picture, that market design for millions of small kind of assets is going to be hard. But definitely the technology can reach there. And I agree, we have bits of pieces of technology ready today commercially. And we need a strategy around how to incentivize everyone so that those technology get together in a one kind of universal policy that allow everything going on. For example, just recently, actually, FERC released a new rule that allowed the energy storage to participate in the market. The same goes for the behind the meter and microgrid. We don't have this kind of rule that allow playing into the market. But also I'm thinking of more kind of technology challenges that exist that probably can be resolved based on the right incentives into the policy. For example, when you think about the big picture of the power system, if we have like 80% penetration of this DR microgrid and everything, then the reliability of the system is a big question still, because you have a low inertia out of all of those devices where usually your big, large power plant works. So yeah, I agree that everything depends on the policy, but I'm thinking the kind of the strategy also is important for policy. It's not just a small policy change in the market, rather it's just big kind of a strategic policy in every aspect of the market design as well as the power system.
Right. So I'm gonna go back to that more detailed question. First, it's for Bill because it's directly for ApolloWare, but then sort of open it up to the panelists. One of the questions around was, is there within ApolloWare, you showed the monitoring capabilities, but is there control? And if there is control, what kind of analytics are behind it that you can talk about for that control?
Good question. Right now, we're just monitoring. And the reason we chose not to pursue what I will call a direct control or load control. I've worked in the utilities 35 years, and I know how really irritated people get when you start knocking off their AC. And so what we've decided to do is—
I don't understand. Why would they be angry?
I have no idea.
Texas. I don't know. I get it.
To compensate them.
Yeah.
So what we've done is provide, what we're doing is providing pricing signals to give them incentives. For example, we're getting ready to roll out a capacity buyback program. And what that means is, if I save at Bandera $55 a kW on 4CP and ERCOT, then with ApolloWare, I can determine, okay, I'm going to give you an alert, and if you want to play, and if you can cut, demand, I'll give you $25 a kW for every kW you drop. Okay, so it's more of a price incentive, behavior change, not a hard thing. We want the members, the customers, to be able to make those decisions based on price. And to briefly answer your other question, I agree with all the panelists. Technology is always going to be ahead of policy. That happens in every aspect and in every industry. The important thing is to approach the regulating community, the regulators, with holistic views of how everybody can win. And I will still promote that energy efficiency is the best way to make sure everybody wins. Okay, and does that answer the question?
That answers the question.
Okay.
Let's see. Looking through some of these other questions. Let's see. So I think we may have time for, I'm looking at the clock as well. We may have time for one more. So what I'm going to try and do, because there's some great questions coming in, but I'm going to try and take it back a little bit more. On the technology side, do the panelists think that the standards that we need are in place? And is the adherence to the standards? This is kind of a trick question because I deal with Sunspec Modbus on a regular basis, and it drives me bonkers because I still have a bunch of problems. On the technology side, are the standards in place? Do the IEEE and Sunspec standards that are coming out, are they covering anywhere all the things that you are worried about, or are there gaps that you're seeing at this point?
No, I will start with this. At least, with Sunspec Modbus, you have something to have problem with.
That's a great way to put it. I'm stealing that. It's mine now.
Because before that, it was all chaos. And
yeah,
I agree that things have a long way to go, and we, deal with it every day. But I'm still grateful that they have come up with something, and I want to see it doing better and getting better. I think that has to basically spread across everything that's currently connecting and trying to connect. And I'm pretty sure even in home automation, probably that's the same issue. Although I don't deal with home automation that much, but we see so many different platforms and so many devices. Some are compatible with this, some are not, and it's all sort of mess right now.
Okay.
But,
well, that makes me feel better that I'm not just missing something, because we see the exact same thing, and we have 2 Sunspec inverters, and I have to write completely different code for them, right? And then I can tell you on the home automation side, because we've dealt with some of that as well. It's similar. There's some issues there as well. So Clayton, I think we're coming right up on 1 p.m.
We are, yeah. I think it's probably about time to wrap up.
So, thank you to our panelists. You have all been amazing and awesome. Thank you so much.
Yeah,
thanks everybody.
Thanks everybody.
Thank you for having us. Yeah, thank you.
Everyone.
Yeah.
Thanks.
Thanks for having us there.
For the folks that did not get their questions answered, please feel free to reach out to Pecan Street. We can do our best to answer as well. Yeah.
And we'll be sending out a follow-up email to everyone that's registered with the recording from the webinar just a little bit later today.
Thank you, Clayton.
Thank you.
Thanks. Bye.
Thank you.
Bye, everyone.
Bye.